Let me tell you something. I'm quite emotional and sometimes I feel sad. And when I'm sad, I really want to dye my hair blue just to make some changes. And it helps. It really helps. So here is an example of what I'm calling to update a previously transcribed word with a new context. This word was die previously, like unaliving myself. After I talked about a hair and about the color and about the changes, it realized I'm talking about changing the color. I'm talking about dyeing. So that is the algorithm we are going to implement in this video. We are going to implement kind of an interface with the buffer to update specific part of transcribed text and not touching the other part, to use the context to make more precise transcription of the speech. So before we go forward, I just want to tell what model are we going to use and what algorithm exactly are we going to implement. What's the idea behind the algorithm? So for the model, I have chosen Whisper because it's state-of-the-art for speech-to-text. It's open source. So it was trained on almost 700,000 of hours for multilingual speech-to-text. It's based on Transformers architecture, and well, currently it's just one of the best tools to use. One significant problem, Whisper is not designed for streaming. Whisper is designed to take audio samples up to 30 seconds long and to produce the text for them. So how it works is you give an audio signal, an audio file, or anything. It should be shorter than 30 seconds. Whisper produces a spectrogram of this audio. It puts it into encoder, and then the decoder part acts kind of like a language model. Basically, it, in autoregressive way, predicts the next token based on the audio signal that was already processed by encoder. So basically, one by one, it will make the predictions of the top tokens. So here we will use the beam search to kind of more optimally select the tokens based on how the tree of selection goes forward. So that's how it works. But how can we do it in streaming mode? First of all, Whisper takes a lot of time to compute. Second of all, it takes huge chunks. It's not designed for the small chunks. So like even if the Whisper can produce text within 1 second, we cannot call it 25 times per second with small chunks. We need some interface for the Whisper. That's what we're going to develop, some buffer with some update events to call it only specific period of time with some specific frequency, etc., etc. So instead of using original Whisper, I'm going to use faster Whisper. It's a great tool. Basically, it's Whisper that was accelerated with C-Translate 2. It's a fast inference for any transformer models. Basically, they took Whisper, they put it here, and there is a set of models you could choose from right now. Give me a second to find them. Right, so here you can see all the projects, popular projects that used faster Whisper. They include Whisper X, they include insanely fast Whisper. It's not listed here, but insanely fast Whisper is one of the models, and it's set to work 70 times faster than the original one. So here you go. To transcribe 150 minutes of audio, it can take just 1 minute. It's with distilled version, of course, with lower precision, so it's quantized a little bit. With batching, that's the main point, and with flash attention. That flash attention is something similar to C-translate. It's something that speeds up the inference of the models. So here, for faster whisper, we have this Hugging Face profile with 15 models. We could choose any, depending on our resources and requirements. So the best ones would be these two. Not these two. I'm really sorry. This one and this one. So the Whisper large version 3 and version 2 have the best accuracy. However, you could also try the distill versions. So to use those models, it's as easy as just writing these few lines of code. You just install Faster Whisper and you specify which model you want to load, and then you just transcribe the audio. So all the rest is for our interface, basically. So what about the interface? Here are a research paper. It's not just one research paper, there are multiple research papers that are focused on building Whisper like real-time transcription system. Most of them have the same concept. So I just selected this paper to show you this concept. The concept is the following. We have some speech. We preserve one part, which we are certain about, and we put it as prompt. You see? So all the yellow is something we absolutely certain about. We don't want to update it. So it goes here to previously predicted tokens to prompt. The rest, however, even if you already transcribed this part, you still keep it in the audio buffer in case you would like to update this transcription with the new context. And there are basically two types of buffers, two types of criteria how to define the size of the buffer. The first one is the length by time. The second one is the length by number of sentences. So basically your audio buffer could be like just 5 last seconds that has been spoken, or like 2 sentences that has been spoken. I prefer to use sentences because some sentences are longer, some are shorter. I would like to keep 2 sentences, at least 2 sentences, to update them instead of doing the seconds. So that's the algorithm, that's the models that we are going to use. Let's get started. Okay, so let's start. Let's say we just started from scratch. I just prepared the packages that we would need. So let's start with the environment. Let's create virtual environment. Let's activate it. And now let's install the packages. So the first thing is to, in my opinion, the first thing should be just to launch the interface. So basically we have 2 parts, right? We have Whisper, we have the interface, and we should put them together eventually. We could start from any point. I think it's easier to start with interface because it's Gradio. Gradio along with Streamlit are 2 very easy frameworks to build your graphical user interface around your AI models. So how do we start with Gradio? We just Google Gradio tutorial on real-time speech recognition or live ASR or live speech-to-text. It's just a question of the keywords. So here we have the example of code to make your ASR based on pre-recorded audio. So here you would record your speech and then you would send it. Here we have a streaming mode. So that's the piece of code we would like. Let's just copy paste it. Let's first create the file. Let's call it, I don't know, demo.py. Okay. So here is the code. We should select the interpreter to run the code if we want to. So what does that code do? So we download the model, the basic model of the Whisper by OpenAI using Hugging Faces transformers pipeline. It's very easy to use. We define the interface as following. We have input as our microphone in streaming mode. We have our output as text. And to make a connection between the input and output, we want to call the function transcribe. So transcribe gets the input. That would be stream is something we don't really need. The new chunk is what's interesting. That's the small piece of audio that is coming to you batch by batch in a streaming mode when your mic is streaming. So this chunk should be added to the stream of audio that we would want to pass to Whisper. And basically, if we just do append, like shown here, our stream will become larger, and eventually it would overcome 30 seconds, and the inference time will growing until the 30 seconds, and then it will hit plateau, and that's horrible, but it should work. Let's try it out. So let's run it and check how the interface works. We are downloading the model, the Whisper base one. And now we can check it out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. I'm just saying some numbers. So we can see how poor the quality is, and that's because it's Whisper base. And we can see that as long as my audio is growing, the inference time is growing as well. We are getting kind of stuck. Let me check for any errors. No, there are no errors at all. It's just syncing. It is just syncing. So that's not what we want to get, right? Look at that. Horrible. All right. So how do we proceed from this? Well, we got our interface working. Let's get our model working as well, the faster Whisper, and then we will try to put them together. So let's see how to run faster Whisper. We go to Github Repository of faster Whisper. We are looking for something like a code snippet, and here it is. Code snippet, we just copy it. We create another file. Let's call it demo model.py. We put this here. It uses GPU, a little bit quantized model with float that takes 16 bits, not 32. It uses CUDA. Make sure that you have the GPU for CUDA, and otherwise put CPU there, or I believe it supports the word auto. Yeah. So I will put CUDA because I can check with NVIDIA SMI, is it? Yeah, I can check that I have GPU, and in fact it has 12 GB of RAM. So in this code snippet, what is happening? So we are loading the model. I would prefer the version 2 because it's still quite good, but It just works a little bit faster from my experience. So we provide the audio file. I already prepared a beautiful sample, in my opinion.
For my brother Anakin, I loved you.
From my beloved Star Wars. So what we do is we just copy the path to it. We put it here. There are other parameters that we could add, like specify the language, specify the number of beams in the beam search. We could talk about beam search in another video. It's a huge topic. And many other things, like to put the prompt if it's a long video and blah, blah, blah. So then we are having segments, and each segment would be time-stamped phrase. So it would be a phrase that was said and the time, starting and finishing time when exactly this phrase was said. So let's run this code and hope that it will work. You were my brother Anakin, I loved you. Everything is transcribed perfectly. Moreover, they have timestamps. We need those timestamps because we will need to cut audio buffer depending on where sentences are finished. So great. Let's start the difficult part. You know what? I just want to make a shout out to a guy that has a channel called Coding Train. A big contributor to the language processing, one of the languages that I learned first. If I learned something from him, is that no matter how difficult or simple your project might be, whether it's just an animation or a generation of the map based on wave function collapse from quantum physics, you still can start with simple diagrams in the paint or in the board or with pen and the note, just to make some notes and to get some general idea. So let's go to paint and let's define what we need for our interface. All right, so what we have is our interface with Gradio. What it will do is it will send us chunks. Let's call them audio chunks. Like, I don't know precisely how big they are. Let's say they are around 25 milliseconds. Okay, so we have our interface for faster whisper. We don't want to call faster whisper transcription every time we get the audio chunk. So what we really want is call whisper every n seconds. So we need some parameter. So that's first that we that's our first node, what we defined. We need some parameter. Let's call it event period, and that would be float. Doesn't matter. That's just an idea. So we would have some parameter. How frequently should we call for a faster whisper? And actually, it depends on your hardware. Because if you have cool hardware, you could decrease it. If you have poor hardware, and let's say you want to update it every second, but your inference time is 3 seconds, it doesn't really matter it doesn't make sense to update it every second. You have to at least update it every 3 seconds. So this parameter depends on a hardware. Okay, so how do we decide? Here's the idea. How can we decide when to call it? So basically, we could create a buffer here with length of this parameter, and we could store chunks in this buffer, basically. And when it is full, when it's complete, then we call transcription. Call transcribe. Important note, this buffer is for updates. It's not the full context that we want to update. So there must be another buffer. So first of all, let us make some notes that we would audio buffer for chunks. That's the first one. We need audio buffer for context. Okay, so how I see it. Let's say we have this long buffer for full context, let's say 2 sentences. This guy, so we already have something here. This guy appends to this buffer, it fits here, and we put this all buffer to the transcribe method. So in this way, we are calling transcribe only once the buffer is filled. So we wait for n seconds. That's a good part. The other good part is that we only put what we need. We only put the things from the buffer. We don't put all the audios that we store. So we will think about how to clear this part when we don't need it. So okay, we have 2 buffers. We have basically this event period is just the length of this buffer, so we could get rid of this parameter. Okay, cool. So let's define our methods. So we have method transcribe. Okay, we have method, let's say update buffer, but I mean the audio buffer, the smaller one. So I would call it listen. So it's like we just listen to the microphone, and when we want to update, then we update, then we call transcribe. Do we need anything else? I don't see it yet. So okay, let's start with this one, and let's build our first implementation. Okay, so let's create a new file. How should we call it? Faster whisper streaming Gradio.py. Okay, so let's start with our interface. Whisper interface. Let's define our parameters there. So we decided that we have an event audio buffer. Okay, we don't know what type should it have yes. So we have context audio buffer. I would put some notes for myself. So when it fills, call transcribe. When call transcribe, put this as an input. So now we have some notes at least. We need function to transcribe. We actually, in this implementation, we don't need to put an input, but I think we should put an input. Okay. audio. We will have something here. We will have listen. Oops, listen. Audio chunk. We are listening to audio chunk. Okay. Okay. So in listen, we need the parameter self update period, and let's make it 1 seconds to wait until we call transcribe again. Okay. Later on, we could add those parameters here, right? To adjust our models. I'm just going to skip that for now. So in the listen, what we're going to do is we are going to append the chunk to event, and if the length of event has reached our update period, then we are appending it to context and calling transcription, right? How are we going to check the seconds? We need a sample rate. Let's make it 16,000, and we will pre-process the audio to have the sample rate. So, okay. I know in advance, because I already wrote this thing, that in inference, you should not give the list, you should give a NumPy array. So I'll just create NumPy array already, import NumPy SNP. I'll just create NumPy arrays. And so how do we proceed here? Well, that's the difficult question, and that's my first video with this in this format, so I'm a bit nervous. But let's keep our mind cold and just append the audio chunk here. How do we append? Is we are calling NumPy concatenation function. Is it concat and concatenate? I believe it's concatenate, right? Yeah. We concatenate two things. We concatenate our previous stuff with the next. I'm writing in the wrong method. With the audio chunk. And let's define our type as NumPy float 16. If we are going to use the quantized model with 16 bits floats, then we should prepare our data in appropriate format. Then, how do we decide whether we want to call transcribe or not? We are checking, right? So we have our length of the buffer. How do we get seconds from the length of the buffer? We divide it by self. Actually, instead of division takes more time than multiplication. Then I could do this one instead. I could multiply update period with sample rate. So basically, our event audio buffer, our audio signal, is just the samples, is just the values that our dynamic should oscillate with. The samples are separated within some specific time. So let's say we got each sample with each 5 milliseconds or 25 milliseconds or 50 milliseconds. That period of time is defined by sample rate. So basically that delta time is equal 1 by sample rate. So basically, sample rate of 16,000 means that per 1 second, we are having 16,000 samples, 16,000 numbers. So if the length of the buffer is more than 16,000, basically because update period is 1, then we have more than 1 second saved in our audio. Great. Then if that happened, then we want to concatenate it with this guy. So we want to concatenate our context with the buffer. We want to clear our event buffer as well. We could just say array, right? By the way, I'm not sure if I should also specify the type here. Let's do it. Doesn't hurt us. We clear the buffer, we append to context, and now we can call transcribe. So here we do self transcribe with this audio. Great. Let's do the transcription then. That's a bit difficult. So here is the piece of code to make transcription. Let's work with it. So the input data is our audio. We could specify the language. Okay, let's make it English. We could specify the prompt. Let's keep it empty as for now. We could specify the beam size. Let's actually do it. Let's add the parameter. The beam size is equal to 5. Okay. We would like to have timestamps, and in the future we will add the prompt. So we'll add this one. We don't need the voice activity detection filter here. So what we are interested in is segments. We already seen how segments work. So basically we want to have a list of this stuff from segments. Let's just create, I don't know, a thing called result, or better to call it timestamped transcription because it's more clear. I already have prepared a piece of code, so I will just copy paste it here. So basically we iterate through each segment. For each word in segment, we are filtering some low probability stuff, and we are appending the dictionary to transcription. So basically our result would be a list with start time, finish time, and text. It's quite too easy to operate with when we'll have it eventually. Okay. So what do we do now? We can just return this stuff. In the future, we could put some timestamps to check how long does it take to make a transcription. But as for now, we already have transcription, right? Cool. That's good news. So now let's try adding Gradio here, and let's see how it works together. Okay. So for Gradio, we need a few more imports. This one, for example. So here's the thing. I prepared some code for pre-processing. Let me show you. So first of all is we resample our audio chunk to the sample rate that we want our model to work with. For this, we need signal from SciPy. Okay, so we have our resample function to help us. And we have this one to just convert it to proper type and make sure that it's normalized. And in case if we have two channels in our microphone, we kind of average it out to have just one channel because the model works with one channel only. So basically, when we have our new chunk, we are getting it, we normalize it, we make sure it's one channel audio, then we resample it to our desired sample rate, 16,000. And now we can just call our model to listen, right? One moment, we don't have a model. Yeah, that's funny that I just forgot the most important part, the model. So let's just stick with this model as for now. So let's say we do this and that. And we need our whisper model as well from faster whisper. All right, we have our model. We have the parameters. We call the model transcribe. We return transcription. As for now, I think we just need text from the transcription. So let's do this stuff. Or why do we work with segments if we have this guy? Yeah, because it not only converts to different type, it also does some filtering, which I like. So I guess with this stuff, we are getting text back. So when we listen, we do transcribe, and let's say that we do self result. I'll explain it right now. Return self result, and let's do the self result as just an empty string. So here is the deal. Here's the deal. When we will call listen here, let me just create a model so that it doesn't say I have some mistakes. I know that I have mistakes, please not now. So we just have text as for now. We don't have certain and uncertain. That's for later. So when we call listen, we want to get text back, right? However, only once in a time we will call transcribe, which returns text. So if we just return text in those cases, and let's say return nothing in all other cases, our Gradio output will most of the time be empty. We don't want to do that. So we could keep our text here. We could create a variable there. Or instead, why not just add another variable in our class to store previous results, right? So we'll store the result from transcribe and return it. So it will be updated when specific time passes, and that should work. So let's try it out. Let's launch it and see if I made any errors. Okay, so another note that I have forgotten to tell you. Gradio is a powerful tool. In just one parameter, you could share your demo to anybody around the world. So here I have my local URL and I have my external URL, public URL for others to share. So anybody could just click the link and check my tool that I just have written in less than 100 lines. So let's check it out. Indeed, I have another bug here. what parameter did I use? I used 90%. So I forgot to add this parameter. Let's try it again. And let's hope for the best. I really feel stupid. I should have put the list here instead of dictionary. Because it's a list of dictionaries. Let's try it again. Let's try it. 1, 2, 3, 4, 5, 6, 7, 8. I am testing Whisper, testing how it works. Okay, it seems like it's working. It seems like it's working quite fast, and it updates every second. I don't see good punctuation. I see that it has forgotten to include 1, 2, 3, 4, and 5. But look at that. It works much better than the example from Gradio with the casual Whisper, right? Great. I think that's a great result. And as for now, eventually, I just want to skip the development part and show you the complete version to not make the video too long. I don't want to have a 2-hour video, okay? Maybe I want to, but nobody would. Okay, doesn't matter. So just let me explain how the complete solution works, the one that I have shown to you at the very beginning. So one of the changes, one of the differences is that listen outputs 2 texts. One is certain, the other is uncertain. So as for now, I'm just separating them with 3 asterisks. So like we could just see the text to the left of asterisk, it will never be updated. And the text to the right of asterisk, it will be updated with the new context if the update is necessary or needed by model. So let's check the changes that I have made to the code. So the listen is absolutely the same. It updates to event buffer if it reaches any certain threshold. It updates many things. That's why I don't call the transcribe, I call the update, because I don't only transcribe here, I also work with prompt, and I update the prompt, and I work with text to check the sentences. So let's cover it one by one. So how the transcribe looks like now. It's a little bit more complicated. So we have our audio, we have our language, now we have prompt. So if you remember at the very beginning, let me actually show you that again. Here in the official documentation, official article on Whisper, there is an encoder and decoder part, and decoder can include the prompt, which is like a previously transcribed things. So if you are transcribing originally, the original idea is that if you're transcribing something very long, like an hour long, then you would definitely want to include the context of previous transcriptions when you do current 30 seconds long transcription, so that decoder finds the better tokens based on the context. Okay, so you add those previous transcriptions as a prompt to decoder, and that's what we are doing in the code right here. So we update our prompt in the other part, and we give it here. The thing that I added just earlier today is an additional prompt called the punctuation prompt. So I have found out that sometimes Whisper doesn't do the punctuation, and from this discussion and from Ukrainian AI Community, thank you guys, they suggested me to add a prompt that has punctuation. So let's pretend that Whisper already transcribed some piece of text and it included punctuation, it pushes the decoder to the tendency of using punctuation, and now it uses dots and commas and all this stuff. So that's the cool trick. That's a quite cool trick, I think. So our prompt includes this punctuation prompt plus the previous prompts that are updated a bit earlier. So we have our beam size, we discussed that, and the VAT filter, I'm not entirely sure if it helps, it doesn't matter. So this piece of code is the same. Here we have our start and end that calls that calculates the inference time. So in my evaluations, I tested large version 2, and I tested distill large version 3. Large version 2 has, based on my hardware, has the inference time of around this amount of seconds, and the distill version is something like that amount of seconds. But distilled version has a lower accuracy, and you could see it in my demos. There are a few demos I have recorded on YouTube as well. So back to our transcription. Wait a second. Yeah, I needed a few seconds to think about this part because I haven't finished it. So let's just keep it for now. Okay, so our transcription is pretty much the same, or very similar to what we have done already. What is update prompt? So we are giving timestamped transcription as an output from transcribe, and we want to update the prompt based on that. What are we going to do that? We are going to keep old transcriptions in prompt. If transcription is too long, it will cut timestamped transcription if needed. So basically, in case the transcription is too long, it will cut it. How it decides if it's too long? Because we have a parameter of max sentences. So basically, if we are checking our transcription and it includes 3 sentences, then the last sentence should go to prompt. That's the first one. So we should remove it from our transcription currently. We should add it to the prompt, and we should clear the buffer with audio that corresponds to this sentence. That's why we need timestamps. So let's get back to prompt update. So in this function, if you remember, in this example with the great audio sample from Star Wars, "You were my brother Anakin, I loved you." Here we have the timestamps for sentences. Sometimes we are getting timestamps for parts of sentences. So like it could have been "You were my brother" with timestamps, then Anakin with timestamps, but we want to cut sentences. So instead of having words per timestamps, we want to have sentences per timestamps. So that's what this big and messy function does. It converts word timestamps pairs to sentence timestamps pairs. And it's a list of dictionaries, basically. Let's get back. So here we have our sentences with timestamps. Let's check how many sentences we have. If there are more than our threshold, then we get our last sentence, we remove it from sentence, okay? We add it to prompt as our sentence, and I just add strip to not make any errors with too many spaces. Like if the prompt already finished with the space and I'm adding another space, 2 spaces, just strip it out. So I said that we are removing the last sentence, right? But we remove it from the variable sense, and we would like to remove it from timestamp transcription variable. So that's what this piece of code does. It's a bit messy and it's difficult to explain, but basically it just checks the timestamps for the sentence that we removed, right? And it just removes all the words with less time starts than this one. And so we're returning the updated version of timestamps with updated prompt. Yeah, so all good. Let's go back. What happens next? Then we update the input audio buffer based on this trimmed time-stepped transcription. Now that I think about, actually we could have just give the sentences. Actually, yeah, it's not optimal. Make your pull request. I'm waiting for your pull request with updated code for my repository. Contribute to open source. You see the bug? You see the bug here? Yeah, some not optimal stuff. Send a pull request. So what does the update input audio buffer function? So we check that if time start is not 0, basically if it's more than 0, it means that we cut the transcription. It means that the first sentence was dropped, and so we start from the second sentence, and the time is different, the time start is different. Then we do the cut of what we get the time, we convert the time to number of samples, starting from which we should make a cut through the sample rate, and we update our input buffer to so we have our buffer, we got our time, we calculate how many samples we should skip, and we do the cut only keeping this part of the buffer now. So that's what this line does. Cool, cool. Let's get back. And so our predicted text is that trimmed part. And yeah, now that I think about it, it could have been just sentences that we already created. So this part only gives us the uncertain part of the text. Okay, so update gives us uncertain part. And here it is. The update gives the self-predicted text, and our listen returns the prompt together with predicted text. So the listen here, we treat the prompt as something certain, we treat the prediction as something uncertain, and we separate them with 3 asterisks. Okay, basically that's all changes. Yeah, that's all changes we have here. Let's check it out the last time. Let's try giving it a longer speech and see how it does. Let's see how it updates a few things. Let's see how phrases to the left are constant, phrases to the right are updating, and that would be a summary of the video. So guys, thank you for watching. That's kind of a summary of the video. That's just a demonstration of the algorithm to see how some things are updating in real time. That's just like a demo of live ASR, real-time speech-to-text translation, not a translation, transcription. I'm really sorry. I hope you enjoyed the video. I hope it was informative for you and you benefit from it. If you did benefit from it, I would really appreciate the comments. And basically, here we go. We have a live transcription. It looks pretty good to me. ISR, not ASR. Okay, some mistakes, but generally it works very fast. Oh, here we go, ASR. Maybe I did pronounce it wrong. Okay, cool. So let's just for the last moment check the inference time. Yeah, and here we can see that some phrases took like around 1 second, some 700 milliseconds, some a little bit more than 1 second, etc. So not much. it could be called a live translation. Less than 1 second or even 1 second and 160 milliseconds is quite fast. And that's version 2, that's model large version 2. If you use distilled models, or if you use small base models, it will be even faster. So guys, thank you for watching. I would really appreciate any comments. I'd really appreciate subscription and the feedback. I hope it was beneficial and informative. See you later. Bye-bye.